Welcome back to the channel, guys. Today we're going to be looking at phasor addition. So, what is phasor addition? It is the addition of two phasor diagrams in order to calculate a resultant waveform. Now, what we need to do first of all is talk about the information we've been given, and then we can start looking at what we are going to do in order to draw these accurately. And we need that accurate drawing of these phasor diagrams so we can then measure our resultant waveform and express it in an equation like you can see here for V1 and V2. So breaking down the information we've got, V1, the information we need to take from this is the amplitude of that first phasor. Now this bit is the voltage, if you like, so this one is going to be 20 volts. And that's going to be our first line that we're going to draw. And then we've got V2, which is our second line, with the amplitude of 30 there, so 30 volts. However, for V2 we've also got this angle attached to the line, pi over 3. Now obviously that's not in degrees, that is a radian measurement, so we need to convert that into degrees. Now, first things first, let's look at V1. Now in terms of what you guys are going to need to do, we're going to need to draw this to scale. Now I'm showing you on this whiteboard app here, so I can't draw it exactly to scale, but we can draw it roughly to what it needs to be. Now depending on the size of your paper, you probably might not fit 20 centimeters and 30 centimeters on your piece of paper. So what we can do is we can scale those amplitudes down, and when we're converting our volts to centimeters, we can scale them down when we're first drawing them, and then scale them back up when we're calculating our resultant waveform. So you're going to need a ruler, and our first line we're going to draw at 0 degrees. Now we're drawing that at 0 degrees because there's no angle attached to this part of the equation. We now need to scale it. For me, again, dimensions on here, so I'm just going to count the dots, and I'm just going to count 10 across the bottom of there. So I'm going to start on here and literally go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you can do 10 centimeters, you can do whatever's going to fit on your page. So make a little note, we've now scaled our thing down to 10. The next step is we need to work out what is this in terms of a angular measurement that we can easily use, i.e. degrees. Now the easiest way to do that is to take our radian measurement, which is pi over 3, divide it by pi, and then times it by 180. Now this will give you 60 degrees. So we are now going to change our ruler angle to 60 degrees, or there or thereabouts, and we can then draw our V2 waveform. Now for this one, I'm going to use a slightly different colour, we'll go blue. Same principle, you've got to draw it to scale, so obviously I'm going to chop this one down, and you've got to use the same scale as what you did for your V1 line, so I'm going to use the scale of half. So for these little marks on my ruler, I'm just going to count 15 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Just about fits on. So now we've got these here, and I can use this just to shift it down a little bit out of the way. We can now look at the rest of the waveform. Now, you need to draw parallel lines associated with V1 and V2. Now what that basically means is, for me, I can copy and paste the. You guys are going to have to draw your lines in at the exact same length and the exact same angle. Now, accuracy is key with this part, guys, because the more accurate this is, the more accurate your resultant waveform is going to be. If you want to be kind of super accurate, we can now mark these on here, noting that these are our parallel lines and not actual phasor lines. we can also start scribbling some angles on here, so we can put down that this is the angle of 60 degrees that we calculated from our radians. And then now what we need to do is take our ruler again and actually look at the parallelogram line. So we join up the top right hand corner to the bottom left on here. Now, two things we need to do from this. We need to draw in the line that goes across the middle, corner to corner. Again, the more accurate this is, the better the resultant waveform will be. We need to measure it, scale it back up, and then also note down the angle. So for me, again, we're just counting how many of these little ruler lines it's going to take. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we've measured it as 20. Obviously we now need to scale that up because we're scaling it from a measurement into a voltage. So we scaled it from half, so we've got to double it. So our VT, so our voltage total for our phasor, will now be 40 because we scaled it up by half. 20 times 2 is 40. Then we also need to get your protractors out. Obviously I've got one built into my ruler. And we now also need to take note of the angle of our line with regards to our 0 degree phasor, so our bottom line that we've drawn. So that there now degrees. So we'll mark that in there as well. Now we can now express this as a full equation of the waveform. So we just fill in the rest. So it's going to be 40 sine brackets 314t plus, because it's phasor addition, not subtraction, 37 degrees, close the brackets, volts. And that is it. That is our phasor addition done and complete. If you really wanted to show off now, you can just label the whole diagram. So we've got our V1 line is this bottom line here, and our V2 line is this one there, the blue one. But in terms of the process involved of phasor addition by a scaled diagram, that is it. So thank you very much for watching. Don't forget to comment, like and subscribe, and look forward to seeing you on the next Electronics with Ben video.